Thank you so much. Thanks for being here. So let's start with this picture here. What do you see here on the picture? Some say a fancy building. Unfortunately, that's not my house, but that's a house and good architecture probably. What we also see, it stands on a solid foundation. And that's also important for generative AI applications because, let's say as an analogy, the house is your generative AI application and we need to build the house on a solid foundation. And for generative AI application, this foundation, as we think, is your data. And even if you want to build bigger buildings or skyscrapers, you more and more need a solid foundation. And that's what we want to talk about with you today. We want to talk about data strategy for generative AI and also why we think the data is your differentiator when you build those applications. My name is Manuel. I'm a solution architect with AWS, and with me is Puria, also here for the second half of the presentation, also from AWS, and we help customers build, secure, and be successful on AWS. Who of you has joined the talk this morning? I think I see some familiar faces. So we have one slide that we reused from this morning. Maybe you can spot it, but otherwise this new content, and we hope you enjoy it. So generative AI transforms industries, and probably in your daily life, maybe you use it in your personal life to create things with ChatGPT, maybe to enhance your emails or to do other things that help you be more productive. Maybe you use it as use cases, for example, for coding companions, which help you code. So there's lots of value for businesses and for businesses to think about generative AI and build applications with generative AI, because this can help your customers to be more successful and get value out of your service more quickly and build on top of this. When you see those generative AI applications that you interact with, you mostly see the top of the iceberg. So you see the fancy application, maybe there's a image generation, or for Photoshop, for example, you can remove different types of the image or add new features into the image. And we always just see the top of the iceberg when you think about that. What's below the iceberg is mostly hidden. And what we think, as I said in the beginning, is a really important topic for generative AI applications is the data foundation. So we need to think about which data we use for the application, how we store the data, how we process the data, which services and fit for the purpose services we use, and how we have data integrity and available for building on top of that. What we also see when we discuss generative AI or large language model in detail is the focus on those large language or foundation models. So you hear probably in the news every week, there's this new foundation model, the greatest benchmarks, it's very well suited for use case X, Y, Z, and there's lots of focus on those LLMs. But what we think you should also focus on, and maybe even more, is what surrounds the LLM and what makes up your application. Because LLMs, there are new ones that come out every week, every month, and you need to be adaptable as well for building with different LLMs for different purposes. So the latest model that's out there might be not the best fit for your use case because maybe it's big, it's maybe expensive, maybe it's also has a high latency. Maybe your use case is more fit for a small cost, low latency model that you can integrate in your application. And then there's all the things that surround this when you also build a normal application, like how do you do DevOps, how do you do responsible AI, how do you secure your application, as we talked about this morning, and also how you do your data foundation. You also need to take care of things like hallucination. So how do we build our model, or how do we build our application so we can limit hallucination or maybe detect it and then output this to the user? I heard a story of a lawyer which used a generative AI application to make up his case for a client, so to draft a case and go to court with this. And he presented a case that was delivered to him by a generative AI application and delivered it to the court. And the judge then said, okay, what is this? The cases that you state here, they don't exist, and your case doesn't make any sense. So the model was hallucinating. He just used the output as is and presented this in court as a case, and that's probably not a good thing to do. So there's also a shared responsibility between using applications and the application providers to prevent or detect hallucination, but also you as the user to know what you can rely on what maybe you have to double check. There was a survey done for chief digital officers at AWS, where we ask, what is the challenge that you see for building generative AI applications? And the top answer was data quality, as you see here in the blue, or finding the right use case, or also implementing guardrails and security, as we discussed this morning. So there's really the need to build this solid data foundation in order to iterate, in order to build good applications. When we think about generative AI core capabilities, you can see those here. So depending on your use case, you can use and leverage different kinds of capabilities. You can generate content, generate text, images. You can also summarize things, classify things, for example, when you use data or document processing, or also do translations to translate from one to another language that you can leverage. When you build an application, you can also use different modalities or input and output, like text or images that we talked about, but also, for example, code. So how many use code companions in your IDE of choice to support you with your coding? So I see one hand. I think that's 2 hands. So that's really, it helps you a lot, makes you faster, but still you have to rely on your own judgment also to use the code generated. So there's different things that you can use and that you can leverage for building such applications. When we look back a little to last year, so we think of the year 2023 as the year of the POCs. So there was lots of attention to generative AI. Lots of people ask, what is generative AI? What is a foundation model? How do I choose the right model? Or what do I do with prompt engineering, and how do I come better with this? When we think of this year, we see it more of the year of production for some features, for some use cases, for some application, probably not for all. Lots of people also experiment with generative AI. But there the question changed a little bit. So how do I prioritize? How do I scale? How do I move faster? And how do I also manage risk and implement, for example, security best practices or guardrails for these applications? So there's more focus on production and really using this for your users. Let's have a quick look at the generative AI lifecycle, how we think the development works and what you have to take care of. So you see here the development environment and the production environment. So first, what you want to do is find a use case and also validate the use case. And as we see on the poll before, or the survey I showed before, finding the right use case is also a challenge for some companies. So you really have to iterate, brainstorm, and also define KPIs and on what you want to do and in order to find the right use case. You would then go ahead and select the model. So select the foundation model, for example, or an LLM if you use text use cases, and evaluate the model. So try out different things, evaluate your use case, and evaluate if what you want to do is possible and how you can make it available to users. When you have evaluated and implemented, you will then have to figure out, okay, are the results that my application is delivering at the moment okay? Can I move this to production, or do I have to do something else? And then you can do different things to improve if you're not satisfied yet. So for example, you can do prompt engineering, where you iterate on the prompt and improve it. We also can do RAG, retrieval augmented generation, where Puria will go deeper in his half of the section. And we can also do fine-tuning, which we will also cover later, so fine-tuning the model that you are using. Let's say you iterated a little bit and found the right model and selected the right model and implemented your application. Then you can go to production, so implement the feature and integrate it into your existing application maybe, or also your new application, so users can interact with this and then get the output that they want and get the value in essence that you want to provide for them. Question then becomes, how do you select the right model? What do you have to think about? And we created a model selection framework to guide you through some steps on what you can do in order to find the right model. So the first thing is the modality. So what do you want to do? Do you want to create text? Do you want to create vision or images? Or do you want to create audio? And depending on this use case, different models might come into play and available for you to select and build upon. Let's say we have a text use case and use language models that are out there. Then different use cases also come into play when we do want to do something with text. So there might be text processing, maybe we want to think about what is inside a document and process this document. We want to maybe do retrieval, information retrieval, so we want to build a knowledge base which we can use to answer questions from the user. Maybe we want to use a chatbot, like for conversational use cases, or agents. And so agents are a way to also provide actions. So for example, an agent could be there to invoke an API that you define. For example, you want to have an application where your users can ask, okay, what's the weather in Munich today? So the application can reason through it and ask an API, because the model wouldn't know what the weather at the moment is. So it could ask an API to get the current weather data and give this back to the user. Next up, okay, what kind of model do we want to use? Do we want to use open source model, deploy it on our own, or do we want to use, for example, proprietary model where we can interact with on an API basis and leverage this for different providers that are out there at the moment? And also, what are some of the key characteristics that we need from the model in order to use it? So, for example, what's the size of the training data that the model was trained with? How much context windows do we have? So how much text, how much prompts can we send and retrieve from the model? What's the cost and the latency, as I discussed before? Sometimes the latency is very important. Sometimes you want to index on cost. And also, can you customize it, for example, if you want to fine-tune your model? Let's take a step back and look at an example. For example, the objective here, or for the sample use case, is we want to have an online travel agency which provides tailored suggestions for people in order to plan their next vacation. And let's also say there's data available which we can use from the users that have signed up there. For example, I know about the past trips, I know about the preferences. Maybe is this person a backpacker, or does he want to go on the beach, where, or on the mountains? And I also have data on recent flights, recent offerings, and I can pack this together and create really offerings tailored to this person. And you can see here as well, there's lots of data involved, and data is really important. So the LLM could be exchanged at some point because there's new development going on, but the data is also what differentiates your business from other businesses, because your data is very unique, so to say, in comparison to others. So we talked a lot about data, but how do we actually implement or have a data strategy, and what's a data strategy in order to make the data available for your application? Let's have a look at what we can get out of data and how we can think of this. So on the one side, you have the data available to your organization, and on the other side, you want to create value out of this data. So let's work backwards from what value do we actually want to create, and then have a look at what data we want to use. But there's also something in between that happens in order to create the value from the data that you have at the moment. And let's look deeper into some of the aspects that we would consider to create value out of the data. And specifically first, let's look at what the value is actually that we want to create. So this could be different things like creating value, reducing cost, or I want to optimize my process, I want to have new features and want to evaluate how well they perform. So let's think of business value and work backwards from this, so what we want to create, and then look at what data we have and what data we need. And data could also be different things like internal data that you use, third-party data or open data that you include and leverage for your application, or also data that you synthetically create. Amazon also provided a payment option for Whole Foods Market in the US, where you could use your Palm and pay with your Palm, and you didn't have to do anything else. And in order to train the model on using different palms and recognizing palms, Amazon used Generative AI in order to create synthetic data for training the model, so to say. Thing is, nobody wants to give up their fingerprints or their palm, so what they did, they created synthetic data that looks like palm data, but doesn't actually exist. And this way, they could then train the model and make this use case available. Inside the box, we have different things to consider. One thing is the data value chain. So how do we actually store the data? How do we make it available? How do we do backup? How do we delete the data? So technical aspects that we will consider. Then we have also data management. So how do we ensure the integrity of the data, that it's available, that it's actually usable, and that the quality is there. And on top of that, also data governance. So who is responsible for the data? How do we store, or what's the data strategy overall, and who's responsible, and what kind of permissions, metrics, and tools do we have in place? It can be challenging to derive insights from the data because of different aspects. So maybe you have data silos, so data lives in different databases, different data warehouses. Maybe you need to overcome this to maybe centralize the data or make it easily available to the persons and the stakeholders that want to use the data, for example, for generative AI applications. Maybe there are also people silos, so people that you need to leverage in order to get access to the data. Maybe you want to make this an automated way to get to the right data and to use the data. And also business silos could be a thing. Maybe you have a holding company with different sub-companies. Maybe there's also compliance issues to share the data among those companies. Those could also be things that we need to think about and that we need to overcome. What we also see is businesses of different sizes building end-to-end data strategies. So once on the left side, you have the data producers. So those are domain experts which have the data and which can make it available to the organization. And on the other side, on the right side, we have consumers. So those are business experts, business users who know the business objective and want to leverage the data in order to derive value from it, in order to achieve the business value that we defined earlier. And we have to make them work together or put them together. So there we have the data foundations team that could be there in order to share what data things have we available. Here's the data catalog. You can use it with self-service and making this an availability. So what's a modern data strategy and how do we think about this? So a data strategy is like your long-term vision on how you manage, store, and process data assets and how you make it available to your persons and how you also manage people, processes, and technology. So often it's also, we look at it from a technology perspective, but there's more to that. Of course, technology is important. How do we store the data, for example, in data lake? How do we make it available to visualize the data for business intelligence, for example, for AI/ML use cases, or for data warehouses? But there's also more than technology. There's also people and processes. So people of different trades, so data scientists, business stakeholders need to work together and make it easy to get data and to share the data among the organization, to have it in an automated way and to make it available. And also lastly, mindset change is also important. So we need to work together, as I said. We need to own the data that we want to make available and ensure the integrity and how we make the data available to a broader audience within the organization and also share the data proactively. Now I give it over to you, Puria, to cover how we can leverage data for generative AI application and what use cases we see there.
Thanks. All right, so let's have a look on how we can actually leverage the modern data strategy that we saw with a data lake in the center and where we have different data sources which can now ingest into the data lake so that we can use it. So this is the technical foundation. And now there are some caveats when it comes to generative AI. So there is different types of data that a large language model or a foundation model, which is the broader scope, can use. And the difference is that the foundation model has not only the text as an input or output, a foundation model can also use, for example, images or videos or audio files. So we have here a scenario of a marketplace where users can look for new car insurances. And on this marketplace, we know our customers. Could also be a new customer, but in this case, we have a known customer. And this user is now using a chatbot to look for a new car insurance. And now let's have a deeper look what type of data we have in such scenario. So the user Bob now talks to our chatbot and is letting him know that he's looking for a new car insurance. And now the chatbot is verifying if the data about Bob is still valid. And where does this data come from? What type of data is it? So this is structured data. So we have, for example, a relational database in the background where we have more information about Bob, where we knew, for example, which was his last car, which was a BMW X3. And this data can be loaded through a large language model or a foundation model. How is that possible? So these capabilities of not only generating text but also generating code is useful here. So what we can, for example, do in the background is we can use text to SQL. So the large language model can actually generate SQL code which can be used to call our structured data sources. And once the model has verified the data that it's still valid, it can now propose a personalized offer for Bob. So here we have another call to structured data sources. So we're looking now for insurance offers, and we are aligning it with the information that we have about Bob. Now, let's have a deeper look into the different types of data that is being used here. And here you can see the typical approach to build a chatbot based on a large language or foundation model. So in the middle, we have our orchestration code where we call the LLM, but we can also call other data sources, and where we can also include a system prompt. And what a system prompt is, we will see in a minute. And through the GenAI application orchestrator, we handle now the conversation with the LLM. So our user input here is that the user is looking for a car insurance. And now we have different inputs that our GenAI application, which is the orchestrator, sends over to the large language model. And the first one is our system prompt. And a system prompt is a text that we use constantly to define how we want to steer the model's behavior. And in this case, we want to generate an assistant who helps us to find the best offer in regards of our car insurances on our platform. This is quite easy. So now the next one is our situational context. So this is where we really go and access our structured data sources to find more information about our current user, which help us to process the further search. But what about unstructured data? So let's say we have a FAQ describing our products, and we can't actually search through them because we haven't enriched them, and they are not available inside our relational databases or NoSQL databases. So how can we still use them and make them part of our data strategy with our GenAI application? And this is where we can use semantic search. So who has already tried out semantic search or heard about this? Okay, we have a few here. And to be all on the same side, so this is based on a similarity search, and for now you can imagine it as you have your huge knowledge base where all your structured information is included, and you can look into it by just natural text search. So let's say you're looking for car insurance for BMW models, use this text and find all the relevant document chunks. This is what we are using here. And additionally, we can also combine this with the user input coming in currently. And if we bring all together, we see now the different types of data that we have. The situational context can also be the conversation history. So for those of you who were there in the morning, what we can also do is we can memorize longer conversations between a user that we have now, or if we had even conversations a few days or months ago. So we can also include them inside the model context. And this is something you want also to take care of when you select your model, because different models have different context sizes. And this is now important, how much data we want to include per request. And nowadays we have models who support, for example, 32,000 tokens or up to 200,000 tokens. And a token is not exactly one word, so it depends on the architecture of the model, how it was created. But as a rule of thumb, you can imagine it as almost one word, but in most cases, it's like a half a word. So now we can see that all this information is used by our orchestrator. And why does this work? what's the magic behind it? So we are not really changing any of the weights of the model. So everything happens as an input to the large language model. And this phenomena is called in-context learning. So the large language model is capable to take new data just as an input and consider it to solve your task. Now, we had also semantic search as a mechanism to go through our unstructured data. And the foundation behind it are embeddings. So embeddings is whenever we take, for example, text documents or images and convert them into an n-dimensional vector. And how this n-dimensional vector is created is through machine learning itself. So we have so-called embeddings models, which are capable of transforming these unstructured data into these vectors, which have then a meaningful position in a vector space. So let's have a deeper look how we can create that. So we have our unstructured data, and then we can now vectorize our data through an embeddings model. And there are open source embeddings models, there are also proprietary models, and you can use them straight away to build your own embeddings pipeline. And now once our unstructured data about our insurances are vectorized, we can store them inside a vector database. So vector databases help us to create an index about all our vector information and then run a similarity search on our indexes. So let's simplify it. Let's just look at it in 2 dimensions. Normally it's more than 2 dimensions in practice, but just to understand the gist of it. So here you see we have different documents, and we have now them being positioned in the vector space at different areas. And whenever documents are similar, they are much closer together. And if you see on the top right, we have auto and car insurance, which are very close to each other, but the dwelling coverage is far away. And this is how we can then run a similarity search based on the vector distances. And now if we look for insurance, we can see that the closest are these 2 points. And this helps us then to find also the relevant document chunks. And now we can take these results and include it as part of our orchestrator, who calls our large language model. One more thing. So what about the semantic context which we are using now frequently? So let's say actually the data that you are retrieving, almost every request needs that. So what you could do there, because what we are doing now here is that we are loading the context dynamically and including it as part of our prompt. And as many models are being priced on the tokens that we use as an input, this can also be a cost factor. So what do you think could we do here to actually reuse the knowledge and don't need to fetch it dynamically? Any ideas? All right, so, sorry? Yeah, exactly. So, I mean, we can cache it in a way when we have machine learning models, if we teach the model the knowledge, right? So, and that's exactly how we can use fine-tuning. So, if we have semantic context that's used a lot, we can actually make it part of the model's knowledge, and that's where we use fine-tuning. Now with fine-tuning, we actually don't need to retrieve the data on the fly, it's already part of the model knowledge. The only thing is, when we want to make that decision, is that it will take some time. You also need the skills in the team, and you have an upfront cost to fine-tune the model, but once it's done, the knowledge is inside the model, and you can then reuse it, and it will be long-term, on a long-term perspective, then cheaper. And this also shows us now how we can actually start and how the complexity increases. So at the beginning, we want to start with prompt engineering. We want to start with retrieval augmented generation and loading our situational context directly from our, from our data sources. One step above, if it's really necessary, or if we want to optimize, would be to fine-tune the model. And then the highest complexity is actually creating our own foundation model from scratch. And this is in most cases not really necessary. So you can actually take an existing model and use it for your own use case by integrating your data to the different approaches that we just saw. Now, let's have a look at the end-to-end ingestion pipeline and also the usage of our application when we look at our different data types. So on the left side, we have our GenAI application. We have the orchestrator in the middle. We have our conversational history and we have also our system prompts. On the right side, we have the different types of data that we have. We have our data sources, which are structured. We have also unstructured data. And now what we can do is we can ingest them so that our GenAI application can actually make use of them. So our ingestion pipeline will take the structured data. Maybe we need to do some additional enrichment, and we can store it inside a data lake or a data warehouse, depending on what our choice will be. And for example, for the unstructured data, we could start with a data lake. Then what we can do is we can actually now make use of the embeddings mechanism to create vector information about our unstructured data. So this is the reg pipeline part. And we can then store the results, for example, inside our data lake, or we can also use purpose-built vector databases. The other part is the situational context. So for the situational context, we can directly access our data lake or our data warehouse. And we can use to do that either APIs that we expose, or we can also use SQL as an API to access this data. And all of these can be then used by our GenAI application, which needs to use the LLM, but also combines these two different data sources. So when we have data which is being used infrequently, and needs to be always there, then we will actually train this purpose-built model to use that data. When we have data that would change, for example, every week, then you can have a frequent pipeline which fetches this data, creates a new version of the model, and makes it part of the model. But now let's imagine that you have data which can change every minute. So let's say, for example, the insurance prices. Then you can't actually tackle that with fine-tuning. Then you would look at retrieval augmented generation, which would be then the best fit here. So this is also important to be aware of how often does our data change. And based on that, we can decide how we want to integrate it as part of our ingestion pipeline for the model. So going back to the beginning of the session, we had also agents. So why do we need agents, or why are agents useful? So when we have a large language model, we can interact with it. We have our system prompt, and we can steer the model into a way to be, for example, an assistant for us. And now when we have an agent, we can actually use the model to create a plan to solve a problem. So let's say we have a task of planning a vacation. So this has multiple parameters. We have to know how long would be our vacation. How many people are we? Is it a couple vacation? Is it a family vacation? What is our budget? What types of activities do we want to do? And now what we can do is we can apply the React pattern. And it has 3 components. And let's look into each of them. So the first one is reasoning. And you can apply reasoning traces with large language models by using chain of thoughts. And chain of thoughts is a system prompt that you can use to tell the model to first create a plan and then use that plan to solve a task. And with that system prompt, the model will first create a plan about the different days that you have, the different locations that you would go, and also the different price tags for these activities, and create your vacation plan as a result. Now, let's say for the transport, we need actual live data, so we want to know what are the flight prices, and this would fail. So this would be good to have a detailed plan, but it wouldn't have any live data. So to make an LLM capable of interacting with its environment, we can use ACT-only. ACT-only has 2 components, calls to APIs, and taking these results to calculate. The only difference is with ACT-only, the model solves the problem straight away. So there are no information about the different sub-steps that the model took to come to this result. And the problem here now can be that the model maybe doesn't take the best fits based on our requirements because it straight away came to the conclusion. So here we don't get the best quality in terms of the results. And to optimize both, we combine them. And this is actually also how we as humans, if we want to be really successful in a task, typically work. So it's an iterative process, and it starts with a plan, with an action, and then we observe the results of an action. And either we are done, or we start over again and run an additional iteration. And the React pattern is nowadays the most commonly used pattern to build agents. And it's based on a system prompt. And also, additional code which helps to specially connect the actions part to APIs. And you can use open source libraries for that. For example, LangChain has implementation of the React pattern. Or on AWS, you can use Amazon Bedrock, which helps you to create your own agents with your own APIs. So now let's have a look on what we have here as agents. So the main foundation is the LLM, plus the React framework, which is the system prompt behind. Then we have our tools and APIs, and now we can connect the dots. So the tools and APIs are, again, situational context. So this is structured data. Now the only difference is that the agent can automatically decide which of the data sources to use for this specific task to solve the problem. And we have also the knowledge base, which is unstructured, and here we have the semantic context. And here again, the model can decide through the React pattern which of these to use and how to combine them. And then we have on the left side the user prompt with the specific task that the user is asking for. And customers are building different types of solutions with React agents. So one of them can be, let's say we connect it to our structured situational context, which describes our fleet of devices. And now we want to query, hey, how many of the devices are actually active? And the agent takes care of the whole chain and just comes back with a natural language response. 500 devices are active now. And if you have seen previously, for example, the observability talk that we had, this is exactly how you want to get insights from your data as easy as possible, where the Gen AI helps you to reduce the operational overhead to get to the real insights. Or let's say we have a customer, and this is one of the most common use cases nowadays, that you have support documentation and you don't need to read through it anymore. You just have a Gen AI agent who goes and gets the needed semantic context and comes back with a summary based on your question. Or an agent can do also multi-step tasks. So here now we have a task to first go into our data source, find out which item was sold the most, and then once this is found, apply a 10% discount campaign. So now the agent is doing multiple things for us, and it can create a plan where to look at, where to get the data, and where to apply the campaign. So now let's bring everything together that we saw. So with data strategy, we are looking at every type of data that we have, and we are bringing it to our Gen AI application to make useful applications that are based on our data foundation. It's important how we integrate it, so there are different strategies to do it. We can use retrieval augmented generation. We can use, for example, text to SQL to access our structured data sources directly. Or we can even fine-tune or create our own model based on the frequency and also how we want, on a long-term perspective, to build up our cost model. And then also, it's important that we have access to this data in our organizations. And it's also important that the quality of the data is good. So based on the quality of our data, the Gen AI application will succeed or fail. Thanks a lot for your attention. And especially after a long day that you came here. And we have also prepared a landing page for you, so I would just guide you through it. Here you have a QR code, and you can directly download the slides. And we have also additional resources. So we have code examples, we have articles around data strategy and Gen AI. And we have also a feedback survey, so very happy also to hear from your feedback, which helps us also to learn from your feedback and run these types of sessions in the future. And yeah, with that, we come to your questions.
Any questions? No questions? Ah.
Yes. Here.
Moment.
How do you evaluate quality of data?
Yes, that's a good question. So, for example, different things are interesting. One thing is bias. So you want to understand if your data is well balanced. So there are also different services which you can leverage out of the box. And then it's also important to clean your data. So any data which actually decreases the quality of the information should be part of our enrichment pipeline. So to really bring the data into the best format. And with that, you can make your Gen AI application successful. Thank you.